Let's jump right in. If you're tackling Cambridge Biology 9700, mastering 13.1 Stroma and the light independent stage, the Calvin cycle, is absolutely essential. Why? Because this exact topic pops up in literally every single examination series. No joke. So today, we're totally bypassing the fluff. We're diving straight into the examiner's playbook to see exactly what they are hunting for in your answers. Listen to this. The principal examiner reports put it perfectly. The classic trap is using the wrong terminology for the wrong context. Guys, this is the #1 grade-ruining mistake students make, often before they've even finished reading the question. You could memorize every single intermediate molecule in the entire Calvin cycle, but if you drop the right term into the wrong context, poof, your mark just vanishes. So what actually happens when your standard everyday revision crashes into Cambridge's incredibly strict context rules? Well, usually it's a disaster. Just reciting the steps of the light-independent stage fails miserably if you don't actually apply analytical depth to the specific stimulus material they give you. The syllabus makes it super clear. Top-tier students show a connected, conceptual understanding that they can adapt to totally unfamiliar contexts. A superficial skim just won't cut it. They want analytical depth. Now, in just a second, I'm going to reveal a hidden examiner clue that literally changes how you tackle any Calvin cycle question. It dictates exactly how you should structure your response. But to actually spot that clue, you need a specific analytical framework first. Without it, honestly, you're just guessing in the dark. Okay, let's dive into this. Section 1, the examiner's framework. Think of this as a 4-step sequence. Step 1, identify the core concept. Step 2, extract the hard evidence or data right from the stimulus material. Step 3, apply your scientific reasoning. And finally, Step 4, package it all using precise examiner wording. We call this the deconstruct, solve, evaluate method. So for example, first you identify that Rubisco catalyzes carbon dioxide fixation. Then you extract the optimal temperature from the provided data. And finally, you reason why the rate suddenly drops off after that peak. This logical step-by-step structure, this is exactly how examiners award top band marks. Moving right along to Section 2, flawed versus perfect answers. Let's see this framework in action. Let's look at a flawed answer first. It uses really vague terms, totally ignores the stimulus data about light intensity, and, classic mistake, forgets the units entirely. A perfect answer, on the other hand, runs like a well-oiled machine. It uses precise terminology like GP and TP, it actively pulls data right out of the provided tables, and it uses context-specific reasoning. It doesn't just blindly state that a reaction happens, it explains exactly why it happens within the context of that specific experiment, even pointing out limitations or assumptions. Okay, I want you to pause for a second and really think about this one. Imagine a student writes this beautifully detailed explanation of Ruby P regeneration. It looks great, right? But they reference the prompt's data without actually citing the specific units of the independent variable. Or maybe they mix up their comparative connectives when describing 2 different light intensities. Where exactly do they lose the mark? Right here. Here is your examiner alert. Unspecific answers completely fail the handling and evaluating information objective. Failing to pull out specific relationships from the stimulus material will completely ruin an otherwise flawless biological explanation. You have to actively identify similarities and differences using proper comparative connectives, and you've got to back up every single comparison with hard evidence from the text. All right, let's turn up the heat a bit. Section 3, the method mark strategy. 0. Yep, a big, fat 0. That is exactly how many marks you're going to get for a wrong final calculation if you don't show clear working and notation. Listen, you could have done 90% of some wildly complex Calvin cycle stoichiometry perfectly in your head, but if your final answer's off by just 1 decimal point and your workspace is blank, 0 marks. No way around it. A huge part of your experimental skills involves knowing your statistics cold. This breaks down exactly which statistical tests apply to which data types, and you need this memorized for the 9700 syllabus. So the t-test, that's for comparing means. Chi-squared is your go-to for categorical data, and correlation tests are for nailing down relationships between variables. If you use the wrong test for data about, say, photosynthetic rates in different stroma conditions, man, that is an immediate red flag to the examiner. So to protect your grade, you need to systematically run through this data interpretation checklist every single time you face a data question. Extract from the tables and graphs, interpret the relationships, calculate those relevant statistics with crystal clear notation, and then draw evidence-based conclusions. If you execute this checklist every time, you secure those crucial method marks, even if your final conclusion ends up having a slight flaw. And here is exactly why that matters so much. Even if your final answer is wrong, method marks can save you. Showing your step-by-step logic, writing out the formula, clearly showing the substitution of your values, and just doing a quick check for reasonableness, that is literally the ultimate safety net for your grade boundary. Whatever you do, never, ever leave that working space blank. Okay, circling back to that open loop from earlier, Section 4, the command word secret. Ultimately, this whole thing comes down to command words. Explain, describe, calculate, evaluate. Look, having absolutely perfect textbook-level knowledge of the Calvin cycle means precisely nothing if you just describe the cycle when the examiner's specific command word actually asks you to evaluate the evidence quality, because evaluate requires you to identify alternative interpretations and how they affect the conclusion. That command word is the hidden key that unlocks the entire mark scheme. So it begs the question, why do top-tier students who know the Stroma back to front and always show their working, why do they still miss the highest marks? Because misinterpreting these command words is the silent grade killer. It is the final puzzle piece we absolutely must fix. So the next time you're staring down a brutal 6-mark question on the light independent stage, ask yourself this: are you just reciting facts from memory, or are you actually answering the specific command given? Solving that puzzle is your mandatory next step. In our next explainer, we are breaking down those exact Cambridge command words. Subscribe to our YouTube channel, Ace the Exams, at acexams_IGCS to master them. Click the explainer on your screen right now, and I'll see you over there.